There are actually many operations you can do with vectors. You can multiply, add, divide, subtract, anything you want with vectors. So for example, if you were to multiply 4 times the vector -2 comma -1, this here is the vector -2, -1. And if we were to multiply 4 to it, that basically means that we're increasing this vector by the size of 4 times its size. So our new vector is going to be this one right here. And we can get what this vector is by simply distributing the 4 to both of the coordinates. So our new vector is going to lie at -8 comma -4, which is in fact where this new vector ends up lying. We have -8 comma -4. To add the vectors, if you were to add 3 comma -5, this is this blue vector here, plus 6 comma 4, what you would have to do, since you're adding 6 comma -4, you are actually going to take this and add it to the end of your first vector, which was 3 comma -5. So the end point, it actually ends up stopping right here after you added it. So your new vector is going to be at this point. And to get what this is, you can simply take the two vectors and add them. You can simply add 3 plus 6, which is 9, comma, -5 plus 4, which is -1. And in fact, again, as we can see, this is actually 9 comma -1. So we can generally follow these rules whenever we're doing any operations. So for this next one, we can do the same thing. Without showing the graphs, we can just take the operations and do them. So we can distribute the 5 to both our coordinates. So we would have 5 times -6, that's -30, comma, 5 times 2, that's 10. And then we can do the same thing with our -7. -7 times 1, so we're going to have a little plus sign because we distribute the negative. We're going to have -7 times 1 is -7, comma, -7 times -3, that's positive 21. So now we can just take these two vectors and add them, just like we did previously. So we're going to add -30 plus -7, that's -37, comma, 10 plus 21, 10 plus 21 is 31. So our new vector would end up being at -37, comma, 31. And we can do something similar if we were talking about letting u be the vector of -3/2, comma, -7/5. So if we let our u be this vector and our v be this one, we can actually represent u, the vector u, by just stating the vector u and v of this form. So if we wanted to perform -10 times u plus v, the vector v, all we would really have to do is substitute them in. So I have already substituted them in here. So instead of writing u, we're going to write this new vector, which was here. And instead of writing v, we're writing 9 comma -8 in its place. So now we can just go ahead and distribute everything. So we can distribute -10 to -3/2. And that is, so remember, we're only multiplying the numerator. So -10 times -3, that is 30/2, comma, again, we're going to multiply -10 times -7, that is 70, positive 70/5. And we can actually simplify this. We're going to have 30/2, that is 15. And 70 divided by 5 is 14. So we're going to have 15 comma 14 plus 9 comma -8. And here, all we have to do is just simply add this again. So 15 plus 9 is 24, and 14 plus -8 is 6. So our new vector, after doing all these operations, is 24 comma 6. So you can simply follow through with the operations as normal algebra for vectors. It may look a little complicated, but it's really not. So I hope that was helpful. See you in the next video.